So we have this baseball diamond here, and the pitcher's mound is 60 feet from home plate. And this is not just a diamond, it's a square. So we have all these right triangles. So the first question is, how far a throw is it from third base to first base? And so from third to first, and knowing that this is a right angle is going to get us the answer. This is the Pythagorean theorem. So we have 90 feet. Okay, a right angle here, and we have 90 feet here. So this distance right here is going to be, well, this is we can just set it up as a similar triangle since these are 45-degree angles. It's 1, 2, square root, 1, 1, square root of 2. Okay, that's a 45, 45, 90 triangle. So it's a proportion that's times 90. This must be multiplied by 90, so the distance is equal to 90 square root of 2. Square root of 2 is 1.41, so 1.41 times 90 equals 127. Okay, so the distance from here to here, I'm going to write it up here because we're going to need this in a second, is 127. And everything is feet, okay, so don't fault me for getting rid of units. Shortstop catches the ball halfway between second and third, so right over here. Okay. This is going to be another Pythagorean theorem because let's draw the triangle. This distance is halfway, so this is 45 feet. This is 90 feet from here to here. We have a right triangle. So we use the Pythagorean theorem, so I'm going to write 45 right there. So 90 squared plus 45 squared should equal this distance. So I'll write that distance right here. And the distance from here to from here to the home plate is the same as the distance from this halfway distance to first base. So D is equal to the square root 90 squared plus 45 squared. So our distance is going to equal 810, the square root of 810 plus whatever 45 squared is. 45 times 45. Boom. 2025. 25, and this is square root of 10,125, which I think is like 101. Let's see. 101 times 101 equals. So it's a little less than 101, so I'm just going to say rounded to 101. Okay, so we have that answer, 101. We already have this one, 127. And now find the distance from the pitcher's mound to each base. Okay, so let's draw some. We already have some of it. Okay, so if 127 is the distance from third to first, it's 127 from home plate to second base. And so what's half the distance? Half the distance would be 63.5. So you can see the pitcher's mound. If the pitcher's mound is 60, here we have 63.5. Let me write that, 63.5 to 63.5 would be dead center. So that kind of makes sense. So we have 3.5 more feet to go to get to the dead center, and then another 63. So 3.5 up to here, right? And another 63.5 to get to there. So that's 67 feet to second. And now what about the distance to first base? The same. It's going to be the same distance to first base as it is to second base. So this is going to be. Let me draw these with the right color. So we have this distance right here, right? So we know that that's 3.5 feet. We know the distance from the dead center of the square over to here. Let's do that in cyan. We know this distance is just half of 127, which is 63.5. And this is the distance we're looking for. This is the distance to first. So what are we getting? We're getting 63.5 squared plus 3.5 squared, and the distance we're looking for is going to be equal to the square root of the sum of those. And I'm not going to do that one because I think I'm out of time.